Alright, what's up guys? In this video we're gonna do some complex analysis. The topic today is contour integration. So we have evaluate the following contour integral. They give us that using the parametric representation of C, where f of z is equal to z squared minus 1 all over z. And then a semicircle is z is equal to 2e raised to the I theta. Theta is between 0 and pi. And then C, for C, z is equal to 2e to the I theta. So I actually did this problem 2 semesters ago, not the one that just passed, not the spring semester, but the first semester before that, the fall semester. I was taking complex analysis, and this was one of the test questions, and it was a really hard test, but this was one of the ones that I got right. I found it in my notes, and I was like, why not post it? So I'm just going to show you guys how I got the solution to this. Contour integration is very difficult because you're not dealing with real numbers. Now, just put you like that. Okay, so the first thing that the integral tells us over here is that we need to find dz, which basically means we need to take the derivative. So that's basically what we'll try to do here. So if we look at c is equal to z is equal to 2e to the I theta, let's find dz. So to find dz, you just use the chain rule, basically. So you would get 2i e raised to the I theta, and then it'll be d theta behind there. So you would just use the chain rule. Okay. So we already know what f of z is. They didn't give it to us, but they gave us, well, up here in the actual contour integral, they just told us where f of x or f of z is equal to. So we just sub it in there basically, and we already found dz. So we sub in f of z is equal to z squared minus 1 all over z. All right, so sub that in. Okay. We know it's going to be f of z, as we did last time, so that's z squared minus 1 all over z, and multiply that by dz. If we simplify, you can actually break this up a little bit. So to be z minus 1 over z dz, that's easy to deal with. Now we already know the limits because of what we were given up here on top. So we kind of like go in knowing that already. So all we have to do is sub in the appropriate information. That's it. And we're using this here. Okay. So you look at z. Well, what is z? Z is 2e raised to the I theta. So you plug that in there. We know it's going to be from 0 to pi. So you just sub in z. Use parentheses. So that's 2e to the I theta. And then it's minus. And then you'll have 1 on top. And then you got another z down here that you put down there. So you get 2e to the I theta down here at the bottom. And then it says you multiply by dz, so that'll be 2i e raised to the I theta, and it'll be d theta. And I just got all the information for what we did up here. So we found that dz, we had this part right here, and theta is between 0 and pi. So, okay, I would probably just try to break this up a little bit. Let me see what I can do. The 2i here is a constant, so we can just pull it out. So that'd be 2i times the integral from 0 to pi. And then on the inside, we just have 2e to the I theta minus 1 over 2e to the I theta and then d theta is behind it. So next, just do a u substitution. So it'd be u. Well, we got some. The best thing it could be would be I to the theta. And this one has it because that's going to work out perfectly. First thing you find du. Well, derivative theta. So you just have I. And we're going to put d theta behind it. So I'll do that. And then we'll have 1 over I du is equal to d theta. So just have to plug everything in correctly. Remember, we pulled the 2i out first. So we pulled that out. Yeah. So I'll stick it on the outside in a moment. So we just changed these I thetas to u. So that's 2e to the u minus 1 over 2e to the u multiplied by e to the u multiplied by 1 over I, and then du is behind it. Alright, so okay, so we gotta change the limits actually. So this would be u is equal to I theta. And what we do to change the limits is we just sub in 0 for theta and then pi. So we sub that in. So this will obviously give us 0. And then we got I times pi, which is I pi. And then these will be the new limits. So I theta will go, no, I'm sorry, I pi goes up front or goes up top. And this one is I theta down here. I'm sorry, no, that's a 0. My bad. Because we got 0. Sorry about that. I theta's up here. So I know it's a little hard to see. Okay. So here's what happens. I'm going to try to break it up a little bit. Because I can end up canceling out. Yeah, I can end up canceling out one of those u's. Hold on, let me see something right quick. So this will be I theta. And then here, on the inside here, I could cancel out the 2e to the u's, but then that would just leave me with negative 1 in there. But I do have the 2i on the outside. So I would just do, negative 2i e to the 2u du, and that's I times pi up there on top, and we had 2i that was pulled out earlier, remember? Yeah, that works perfectly because basically here's what I did. I just did a little bit of reducing. So I guess I'll do it over here. So we got negative 2i e raised to the 2u minus 1 over 2i, and we basically just end up doing some changing there. That's what happened. So we could pull out, well, not that 2i, we can pull out this negative 2i. I kind of want to put that one back out down here. I'm going to forget about it. I'm going to try not to forget about it. So you pull that out. So then you'll have the integral from 0 to I pi. And on the inside we'll have e to the 2u du. Okay, so I guess we can put that on the sheet. So to do this, just do another u sub. It would be in your best interest to use a different letter, so I'll use V. 2u up here is obviously the best u to pick. So I'm going to use V because it's the next closest letter. Excuse me. Then we find dv over du. Okay, and that's just 2. And then what we end up having is basically 1/2, basically. So we'll get 1/2 du is equal to dv. All right. So the negative 2i comes out, or came out front, times that by 1/2. You have the antiderivative from 0 to I high. Oh, actually, nope. I had to change the limits because we did do another substitution. So I'll leave that blank. I'll just put e to the v dv in there. All right, let's change the limits. So v, or not v because we're doing, or u because we're using v because we had to do a u substitution twice. So v was 2u. So all we had to do is plug in our original limits, which was 0 and I pi. Okay, so if we do that, we'll have 2 times 0, which obviously gives us 0. And this would be 2 times I pi. And that's just 2I pi. Okay, so it's negative 2i times 1/2 times antiderivative from 0 to 2I pi. And then on the inside, you'll just have e to the v dv. Well, we know e to the v dv is e to the v. Okay, so we have negative 2i times 1/2. I'm sorry, that looks like a z. It's actually a 1/2. If we do that, that'll just give me I because the 2's will cancel. You multiply by 1. Yeah. So then we'll just end up having I on the outside here. So that'd be e to the v. And that's going to be from 0 to 2I pi. So that goes first, the upper one. You know, the lower one always goes last. So you plug that in. So 2i pi, you plug that in for v. We already know we're going to get 1 here because e to the 0 is 1. So you just plug that in. This will give you 1, I believe. And then I know I'm going to get 1 right here because e to the 0 is 1. So this will be 1 minus 1, which is 0. The I was on the outside, so I is multiplied by 0 is 0. Yeah, just making sure I had everything correct. Yeah, so that's e to the 0, or e multiplied by 0, or I times 0, excuse me. That's just 0. Okay, yeah. So we're looking okay. So that takes care of that part. Now we got to do the other part. So it's going to be from 0 to I theta. And remember the other part. Remember, basically what we did is I just split it up a little bit. So we're just dealing with this part now. We took care of that part. That's what we were working on. So we got 1 over 2i du. Still the variable u because we did a substitution. Okay. So yeah, because we had to do a u substitution for the first part, but this was originally u, so we'll leave it that way. So basically integrating a constant. So this is 1 over 2i multiplied by u from 0 to I times pi. Actually, so that the substitution can be made a little bit easier, I'll just write this as negative I times u all over 2. That'll make it a little easier. So this will be from 0 to I pi. I pi goes first. And this will go last, or you sub the 0 in last. The 2i that we took out up here at the beginning, remember? This comes back to where we were at the beginning. And I kind of wanted to write it down because I didn't want to forget about it. So thankfully I didn't. So that positive 2i that we pulled out earlier, we need to find what that's going to be. Then that'll go in parentheses. So this would be pi over 2. This would be minus 0, be pi over 2. So this would be 0 minus pi over 2. So you can break it up a little bit. It's obviously just pi over 2. Actually, it's a negative. Yeah. Okay. So now you just take the 2i and multiply it by negative pi over 2. Well, 2's cancel. You're simply left with a negative I pi. That's your answer. Alright, just a quick rundown on what we did. Just given this contour integral, it really wasn't that bad. I had to be a little careful. I was breaking it down here, but we were able to see, so we just plugged that in. We already knew the limits. The contour integral said that we needed to find dz, so we differentiated it and plugged everything in. And that's pretty much all there is to it. Alright, well, I will see you guys for the next one.